morning, everyone. Welcome back. Today we are going to start off with a new problem, negative weight cycle. So this problem is basically the Bellman-Ford algorithm. We'll implement that. In Bellman-Ford algorithm, it is same as that of a Dijkstra's algorithm. That is, the similarity is that we use that algorithm to find the shortest distance from source to some particular other node. Okay, but the problem with the negative Bellman-Ford algorithm is like it don't work with the negative cyclic graph. Okay, and so the condition that should satisfy with the Bellman-Ford algorithm is like it should have a directed acyclic graph. It cannot work with a cyclic graph. Okay, and Dijkstra's algorithm is basically used to find a shortest distance from source to destination with no negative edge. It should not contain any negative edge, and that is taken care by another algorithm, Bellman-Ford algorithm. So finding the negative weight is like we use Bellman-Ford algorithm to detect that graph contains a negative weight cycle or not. Okay, because the Bellman-Ford algorithm can't work with a negative weight cycle. Okay, so it will be, we'll see in the further solutions like how it's going to detect. Okay, now we should see some example. Okay, now I'll show you some example. Now this is a what was my question, like negative weight cycle and graph edge will be given, like edge will be given, it will be like a double dimensional array, and number of vertex that is containing it's all will also be given. Okay, and we have to return like a 0 or 1. Okay, 0 for no cycle is present, and 1 that cycle is negative weight cycle is present. Okay, so we'll see in here now. See, the number of edge, that is 3 will be given. Okay, number of edge, that is 3 will be given, n value 3 will be given, and the edges will be given. Okay, now this values is for the this one is the source. Now you should remember the order. This one is the source, this one is the destination, and this one is the weight that is given. Okay, this one is the weight that is given. Okay, so from 0 to first vertex, and the weight is given as -1. Okay, so weight is given as -1. From source 1 to 2, from 1 to 2 the source the weight is given as -2. Okay, and from 2 to 0, 2 to 0 weight is given as a -3. So you should this only this edge will be given. Okay, you have to draw this by your own. Okay, and yeah, we should proceed with how we can find the negative weight. Now first we will declare a distance array, and we will since the source is not given. Okay, so distance array for n is equal to 3 only will declare with the size of 3, and for all of the content we'll give a something like a infinity value, will give it for all, but for the vertex that we will consider as a source vertex, we'll give it as a 0. Okay, we'll give it as a 0. Okay, then we'll start off with the algorithm like for every vertex, like for 0. Okay, we will be checking a condition like a distance uh, distance of source. Okay, distance of source, that is this distance. Okay, any of the distance. Okay, this should be, if it's greater, okay, if it's greater than the distance, if it's greater than the distance of any other traversal distance, like for example I'll give it over here itself, like this. If this distance is like 6, okay, and from here to here traversal, if we are getting like a -1, so -1 is less than the 6, so we'll remove the 6 and we'll put -1 over here, okay. So basically we'll see the condition. This is not the exact one, just for example I've given when we are going to fill up this distance array, okay. When are we going to fill up this distance array? Now now moving towards the programming part. Now first we have seen, like we will first declare a distance array, okay. This will be a new int of this, whatever the size number of vertex will be given, we'll just take it that itself. And for each and every vertex, we will check for n-1 time, okay. I'll explain once I'll come to that part of the program. I'll explain that one, okay. Arrays dot fill, initially we'll fill this distance array with the infinity value. So infinity value we will declare in Java as an integer dot max value. Integer dot max value, okay. Integer dot max value. And for the source and distance of source, since source is not given, since we have to find the negative weight cycle, so you can give any of the vertex as a source. So initially I'm giving it 0 as my source, and I'll for that this source I'll corresponding 0 I will store in the distance array. Now for count, okay, now you have to okay, now count is equal to 0, and then count should be less than equal to n-1, and then count should be plus, okay. Now this one I am taking, like for each and every edge we have to perform the operation n-1 times, so that in all the graph all the vertex is checked for its least distance, okay. And inside this we will be running our main loop, okay. That is the we'll handle each and every vertex, like fill j is equal to 0, and j will, this we are taking for the vertex part, okay. ed j edges dot length, okay, and then j should be plus, okay. Now see, edges dot length, see if we have taken this example, so n is equal to 3, so 3 vertices are there, so this will be running from 0 to 3, okay. For each and every vertex it will run, and this will take care, like for every vertex, okay, every vertex, like 0 is running from 0 to n-1 times, then when 1 will be there, then 1 will be running from 0 to n-1 times, then again for 0 1 and 2 for j is equal to 2, it will be running from 0 to n-1 times, okay. So for each and every edge we'll check the condition. Now we'll come to the condition part, and int source, okay. Now first we have seen, like we got this from here part we got this part, okay. Now from this part we got, okay, and we'll be extracting, like for 0 j edges of j, okay, edges of j, first j is 0, so this will take the first 0th part, okay, for 0th part. And for 0th part, this one is 0, this one is 1, and this one is 2, and 0 1 is the source, then it's the destination, and then is the weight, okay. So source is equal to here edges of j and 0, this will be the source, and then destination, that will be edges of j and 1. The 1 will be the destination, and then the weight will be edges of j 2. And then we will, what the condition we were talking about in the previous, the explanation of the example, this is the condition, like distance of, like for every the vertex, that should not be equal to the integer dot max value. Means it should start with a source vertex or from the vertex that has already been previously visited. So we will check for a condition like source vertex value that will be in the destination should not be equal to the integer dot max value. Should not be equal to integer dot max value means it should not, first of all it should be like a source vertex, and if it's some other vertex, if it's some other vertex, then it should not, it should be a vertex that has already been visited once, so the max integer dot max value has been replaced by some other value, has been replaced by other value. Now one more condition, this is the main condition, this is the some initial condition. This is the initial condition, and then we'll be going for the main condition, is like distance of the destination, if it's greater than the distance of the source plus the weight. If this is the condition, then the same condition we will initialize this. Now we are, first of all we are checking if it's greater, then we'll replace this with the smallest value, then we'll replace it with the smallest value. Then we'll replace it with the smallest value, and till this one. Till this one. Now for each of the vertex, like 0 1 2, first it will run for 0 1 and 2, this whole condition will be checked. Then again the second time it will run for 0 1 2 3 times, for all the 3 vertex. Then again it will run for the third time for 0 1 and 2. Now this will be running for from 0 to n minus 1, that is 2. 3 minus 2, 3 minus 1, that will be 2, but it will be running only 2 times, 0 and 1. So the condition that will be n minus 1 will be satisfied over here. Now why we are doing is, like for the fourth time, now the same condition if we will apply, then the inner one, if we will apply the same condition again, then it should not occur, because only n minus 1 times it should be checking. If the fourth times also it is like finding some value which is satisfying this condition, that means it's endless. And it will be like again and again it will be giving a smallest value, since there is a negative edge. So the fourth time when it will give, then we will return like n negative cycle is present, and we will not proceed it with further. Like cycle is present. Else if this condition is not occurring, that means no cycle is present, and then we will return 1. And then we'll return 1. Now we should run and see this. Now what's the problem? Int. Now for all the test cases, now this is necessary to pass all the test cases. Now it's not passing. We should see what's the error is there. 1 2 not equal. Now weight, this should be greater, source comma weight. No, it's okay. Oh. If passing it as 0 by, no, it's necessary, like for all the test cases should be passed, then only we can say out all the whole the program is checked and it satisfy all the conditions of the necessary. Okay, now it has successfully passed, okay, all the test cases. So yeah, it was all about negative weight cycle. Okay, hope you have understood this one, and if you have any doubt regarding it, please do put it in the comment section and I'll try to reply. Okay, and if you have any other idea approaches to solve this particular problem, so even put your ideas in the comment section. Okay, thank you.